Welcome to my 12th presentation for the team of purchase and contracts. And today's subject is how to negotiate cost for the machining items logically. Overall, this is my 86th presentation considering all the YouTube presentations that I have made so far. What I plan to include in this presentation are what are the various machining processes, what influences the cost of machining, technical and commercial aspects, approach for negotiating machining cost based on the illustration, how to estimate the apportion plant and machinery cost, how to compute manpower cost for machining, how to compute cutting tools cost per hour for machining items, how to compute manufacturing variable cost per hour, how to estimate marketing variable cost, how to compute overheads, how to estimate vendor margin and taxes, how to estimate machining cost per unit, which includes equipment, manufacturing variable, manpower, and cutting tools, pitfalls and negotiation strategy for machine items with a win-win mindset, and learn more from my blogs related to the Udemy course. What are the various machining processes? A list of 18 manufacturing machining processes applicable in the manufacturing and engineering industry are as follows: turning, milling, grinding, boring, reaming, threading, broaching, hobbing, shaping, shaving, and so on and so forth. The above 18 machining processes can be performed on general purpose machines or special purpose machines or CNC machines. So to that extent, the number of processes will go up. Further, a list of 6 modern machining processes is as below: laser cutting, water jet cutting, plasma cutting, electro discharge, electron beam, electrochemical machining process. The process engineers design the machining sequence and process. Our scope of work is limited to the general purpose machining for this simple understanding. Now, engineers they design the sequence and combination of above processes with the appropriate cutting tools, jigs, and fixtures. This essentially focus on the negotiating rates for conventional processes using GPMs and first principle costing. A similar approach can be applied for any other type of machining processes. In any industry, casting, forgings, or bar stock produced using different technologies from raw materials like steel, non-ferrous metal, etc., are some examples of machine items, as mentioned in my previous last two blogs, presentation number 10 and 11 in the month of April 25. This is an image of a complex item to be machined with a combination of machining processes. It shows different kinds of operations being performed. Now, what influences the cost of machining? The technical aspects. The technical aspects are given in these two columns. Column number 1, technical aspects. Number 2, description. Like row number 1, types of machines used. Uh, Lathes, milling, drilling, grinding, and so on. Different base. These machines have different base costs and productivity. This process can be manual or semi-automatic. That influences the cycle times and machine age and condition and downtime and frequency of tool changes. They influence the cost of machining. Machining parameters: metal removal rate, which is the cutting speed, feed rate, and depth of the cut, tolerances and surface finish, multiple passing speeds, cutting tool, the type of tools like HSS, carbide, ceramic, having different lives, cost and performance characteristics, tool geometry, tool change frequency, then jigs and fixtures, then operator skills and productivity, batch setup time, very important parameter, because a longer setup increases the cost per piece, repeatability, economies of scales, large batch sizes dilute setup fixtures and program costs over the more parts, material type and machinability, material hardness, affecting cutting speed and frequency of tool changes, chip formation, etc., and quality and inspection requirements in process and post process. So my focus will be on the costing aspects, not on the technical aspect. This is just to give an overview. Commercial aspects are quantity or number of pieces to be machined, the rates of the raw material type and sizes like castings or forgings, etc., which we have already covered earlier. Skill, labor availability and rates, competition, payment terms, customer specific requirements like traceability, packaging, labeling, etc., and vendor relationships. Approach for negotiating machining cost. 5 templates have been given in this presentation as per the tabulation given below. For example, for the cost element, there are 9 cost elements which have been considered. The first cost element is plant and machinery related cost. It is given in the computation, it is given in the template RT resource template 1, and this will be ultimately carried to the template RT4 column 2, which I'll be sharing one by one. Similarly, cutting tools, how to do the computation is shared in the resource template RT2. This is given in column number 3, and it will be taken to resource template RT4 column number 9. Similarly, manpower cost, manufacturing variable cost, marketing variable cost, these are given in different either in the slides or the resource template. The resource template is given where there is a little more complexity. Uh, Now these will be ultimately taken to the final templates RT4 and RT5, which I'll be sharing with illustration of the actual cost to be computed. Approach for negotiating machining cost. Who should negotiate? A team of competent professionals with the necessary skills. Out of the 40 skills that I have shared in my 9th blog on 11th April 25 on YouTube and LinkedIn must negotiate the rates and terms. The computation of the cost is demonstrated in the following slides and resource templates RT1 to RT5, and these 5 blank templates can be directly put to use by professionals to populate data and negotiate machining charges. What I am saying is that the 5 templates which have been populated by me for your understanding, this can be data inside can be removed and you can use them as it is for negotiating the costs. Now let's look at the template 1, resource template 1, how to estimate and apportion plant machinery cost. Now it has got 4 columns. Column 1 is cost element, column number 2 the basis and assumption for the cost, column number 3 the estimated cost per annum, this is the assumption, and last one is the cost computed rupees per hour basis, which is to be taken to ultimately to resource template 4. Now the cost element for plant machinery are machine depreciation, row number 1, then the machine maintenance, row number 2, financing cost, row number 3, and total. I have assumed that equipment costs, say set of lathes for the purpose of turning operations. I am limiting this to turning operation for this computation. Let's assume that the total cost for the meeting the production demand is of the equipment a set of lathes is 99,60,000 rupees, and let's assume the depreciation rate is 10% considering a 10-year life and straight line method, and working hours assuming 2 shift working is say 4800 hours, which is based on the 8 hours per day into 300 days into 2 shifts. So the total estimated depreciation cost in column number 1 to 3 is rupees 9 lakh 90 996 9,96,000 rupees in the column number 3, and to divide this by the number of hours 1400, this is works out to rupees 208 per hour for the machine depreciation. Similarly, machine maintenance, let's assume that the total cost for maintenance for repair, equipment, supplies, overhauling spares, oil, lubricants, etc. is say 12%. So this is to be approximately 1400 rupees. This is given in last column, which is works out to rupees 1,20,000 assumption divided by 1425 rupees per hour. Similarly, financing cost, let's assume that the 10% is the loan amount, 10% is the financing cost, and the loan amount is say rupees 70,80,000 out of the total of 99,60,000. So the total cost works out to be rupees 7,08,000 divided by 4,800 hours. So it is 146 rupees. So if we add up all these 3 costs, that is machine depreciation, machine maintenance, financing cost, it works out to be rupees 379 per hour. This is only for the lathe, set of lathes. In our housing example which I have taken in this picture, there can be different kind of operation which I have assumed. It is housing, it is turning, it is boring, it is grinding and milling, etc. So so based on this assumption, let us assume that based on a similar concept of determining the cost, the rate of milling is works out to be say rupees 419 per hour against lathes of rupees 379 per hour. Rate for boring is say rupees 579 per hour, and rate of grinding is rupees 779 per hour. This is just a assumption for the simple of understanding, and these will be carried out supplementary to resource tablet 4. Now, how to determine the manpower cost? Now, the negotiating person must ascertain the various cost elements at the vendor end and estimate cost per expenses incurred by the vendor towards employee cost, overhead and marketing variable cost, etc. For the manpower cost, let's assume that the skilled labor is say 300 per hour, which is based on, let's assume that it is 60,000 rupees per month, assuming 8 hours per day into 25 days in a month or 200 hours per month, which works out to be rupees say 300 rupees 300 per hour for the skilled person. This will be carried to resource tablet 4 column 7. Similarly, rate of the unskilled, let's assume it is 30,000 per month in the Indian context, and it will be 150 per hour to be taken to resource tablet 4. For the simplicity, for understanding, I have just assumed that the skilled labor cost and unskilled labor cost per hour are uniform for all operations, but actually in real life, the the cost of machinist or lathe operator or milling machine operator or grinding operator extra will be different, so this cost can actually vary. So automation reduces the labor involvement. How to compute the cutting tools? There are different kind of tools which have been assumed in this working, which I'll be sharing. Different kind of inserts and for uh, uh, for turning or boring, etc. I'll be sharing this one by one. Now for the lathes in column number 2, in this tabulation I've given 5 column table, which on the first column is equipment, number 2 is the what kind of cutting tool is required, column number 2, column number 3 is the estimated cost per unit of the tool, and column number 4 is the indicate the estimated life which this tool can produce, and column number 5, last one, is the cost per unit based on this life, including the servicing of the tool, resharpening of the tool. So let's say lathe. This can we can use the depending on the type of the item to be produced, item to be machined. Carbide insert, this can be carbide inserts or turning face or facing or chamfering tools, etc. Let's assume the average that cost per unit is 300 rupees and estimated life is 50. So cost per unit for the lathe will be 6 rupees per unit. Let's look at the milling machine. There the cutting tool will be milling cutter or end mills for milling machines. Then let's assume that the cost is 500 rupees and the row number 2, and estimated life is 40, so cost will be 12 rupees 50 paisa per unit, which is column number 3 divided by column number 4, and so on and so forth. So I given in this last column the cost per unit for different machines, and these will be taken ultimately to resource tablet 4. Now next is the manufacturing variable cost. Here the picture shown is only for the um, gauges QC equipment, but there will be many more manufacturing variable cost elements which I'll be sharing. Now this has got 4 columns. Manufacturing variable cost, column 1 is the type of manufacturing variable cost, number 2 the description of the expenses, number 3 the estimated annual cost, and last column is cost per unit. Now let's say that power consumption, it is basically based on the rating of the equipment to be used. Let's assume that the production line and warehouse machines use 10 kilowatt per hour and electricity cost is rupees say 8 per kilowatt hour. So the cost will be rupees 80, which is 10 kilowatt into 8 per hour. Manufacturing variables in a machining process are like cutting consumables like cutting oils, lubricating, oil grease for equipment, etc. And these we are assuming that to be spread over 1400 hours, and this may also use the compressed air also. So let's assume that annual estimated cost is say rupees 3,36,000. So the cost per hour for this manufacturing consumable will be rupees 70, which is column number 3, rupees 3,36,000 divided by 4,800, 70 rupees. Likewise, jigs and fixtures and QC gauges and etc., which I have given that description here, and simple computation of that. So total cost on the manufacturing variable cost, they work out to be in the last row, which is rupees 181 per hour, considering all these power consumption, manufacturing variable cost, jigs, fixtures, and QC gauges, etc. And these will be taken ultimately to resource tablet 4. This was the resource tablet 3 for manufacturing variable costs. How to estimate marketing variable cost? It is a simple one. So I have not taken a template, just given on a plain sheet in the PPT format, and this includes when marketing variable cost includes packaging, protective coatings, labeling, branding cost, freight, insurance, warranty, etc. to be borne by us vis-a-vis vendor. And let's assume that the marketing variable cost of 3,45,660 rupees. So this works out to be rupees 72 per hour, which is 3,45,600 divided by 1400, 72 per hour. So it works out to be rupees 108 per unit. In a similar way, there is rupees 72 per hour into 90 minutes per 90 minutes the total time. I will be taking up this separately, how to compute this, because the total 90 minutes have been assumed in one of the slides to be taken subsequently. So this will be taken in resource tablet number 5. Overheads. Now these overheads elements cost include admin and staff salary, rent, security, testing, certification, utilities, and so on and so forth. Let's assume that this is rupees 9,12,000 rupees per annum, and to be a portion over 1400 hours. So this is rupees 190 per hour, which works out to be 200 rupees per unit of the machine part by applying 1 rupees 190 per hour over the throughput time. The throughput time concept I'll be taking subsequently. The total time taken is 90 minutes. I'll be sharing in the one of the slides. So this is just simply prorated to 190 rupees per hour into the total number of minutes used. It will be ultimately taken to resource tablet 5, the last slide. And of course we can also add the like statutory costs etc wherever required. How to estimate vendor margin and taxes? Vendor margins. These are usually based on the type of technology used in the manufacturing, vendor infrastructure, terms of equipment, process, tool, jigs, and fixture locations. Hence, it is charged as a percentage of the total cost. This is to be captured in the resource tablet RT5, row 5. Similarly, taxes like GST or other applicable taxes are to be added at the statutory rate and should be separated from the base cost. And this is to be captured in the resource tablet RT5, row 6. How to estimate throughput time for the machine item? This is one of the very important slide. Now, arriving at the cost per unit over time is crucial as it influences how long the machine will be utilized for processing the workpiece. The process design engineers, they must determine cycle time or throughput time for each manufacturing process based on the engineer's designing of the material to be processed and the machining capabilities. In this illustration, the following throughput times have been estimated for manufacturing operations for costing and will be carried to the resource tablet for column 5. Let's assume that the method engineer or process engineer or industrial engineer has estimated the turning time for this component say 50 minutes per unit. Let's assume that this involves a milling time of 20 minutes per unit, boring time of 25 minutes per unit, grinding time of 30 minutes per unit. So all 4 operations put together, turning, milling, boring, grinding, they add up to 90 minutes per unit. The negotiating team must enforce transparency and rationality while negotiating these rates. Now, this is a very important resource template RT4, which is one template prior to the final template RT5. Now, it is better to understand this. Now, it has got 10 columns. Column number 1 is process. Column number 2 is the equipment cost per hour. Column 3 is manufacturing level cost per hour. Column number 4 is machining hour rates. Column number 5 is throughput time per piece. Column number 6 is machining cost. Column number 7 is labor cost for the skilled labor. Column number 8 is labor cost for the unskilled labor. And column number 9 is for the tooling cost. And last one is the total cost. So I will take one simple example for understanding. Now, equipment cost per hour. It is taken as rupees 379 from resource template 1, and manufacturing level cost is taken as rupees 181. The total is 560 in column number 4. Let me go back to resource template 1, where I'll be showing how, from where 379 has been picked up, and resource template 3 from where 181 has been picked up. So let me go back to resource template 1. So template 1. So here if you look at the last row, the total cost of machining depreciation, machining maintenance, financing cost is 379 per hour, which has been taken up there. Now let me go to resource template 3. Here look at this manufacturing bill cost, which is power consumption, manufacturing consumable, jigs and fixture cost total, and the last column, last row, it is rupees 181 per hour. This is what has been taken in this. Let me, yeah, so 379 in the row number 2, turning cost and manufacturing bill cost 181, total add up to rupees 560, which is column number 2 plus column number 3. Now throughput time is assumed is 15 minutes. This I had taken just 2 slides back. Yeah, this one. 15 minutes turning, milling 20 minutes, boring 25 minutes, etc. So now, therefore, the machining cost per piece, it works out to be at the rate of 560 rupees into 15 minutes. For 15 minutes, this is 140 rupees, because 560 rupees was for the 60 minutes. Similarly, for the milling row, it is 200 rupees, which is 600 per hour basis. For 20 minutes, it is 200 rupees, and so on and so forth. So if you look at this total pure machining cost for these four operations, turning, milling, boring, grinding, given the last row is rupees 1137, which is sum of row 2 plus row 3 plus row 4 plus row 5, 1137. Now labor cost, if you recall, I had taken this labor cost as 300 rupees for skilled one and unskilled one 150 rupees in the initial slide. So assuming that 15 minutes is the turning cycle time, throughput time. So applying this 15 minutes to this cost of 300 rupees per hour is 75 rupees, which is 300 multiplied by 15 minutes divided by 60, which is 75 rupees. Similarly, for the milling, the cost and labor cost works out to be 100 rupees, which is 300 skill cost into 20 minutes by 60, and so on and so forth for boring and grinding. So this works out to be 450 per piece. Similarly, for the unskilled labor, the minutes throughput time remains same, which is 15 minutes. So the cost will be 15 minutes into 15 minutes into 150 rupees divided by 60, so 37.50. Likewise for milling, boring, grinding, so this works out to be rupees 225 per piece. Tooling costs per piece, I had shown this earlier in the resource template too. Let me go back. So this is shown for turning 6, milling machine 12.5. Let me go to resource template 2. Yeah, here if you see last column, in the lathe it was 6 rupees, milling machine was 12 rupees 50, and so on and so forth. So this is what I have transferred it to this resource template 4. So turning is rupees 6, milling is 12.50, and so on and so forth. So this adds up to say 31 rupees 20 paisa, say 31 per piece. So if we add up all this cost of machining cost plus skilled labor cost plus unskilled labor cost plus cutting tool cost, it adds up to rupees 1843 per piece, uh, which is given in the last row. This will be ultimately taken to the final total cost. And because this table represents only the equipment cost, the manufacturing variable cost, the manpower cost, and the cutting tool cost. Now this is the final template, which is the resource template 5, to show the total cost per unit for a machined item. So machining cost is 1843 per unit of machined item. This we have just taken from the resource template 4. Here last column, last row 1843, which is shown in row number 1. The marketing variable cost is 108 rupees per unit, which is as per the computation in the earlier slide, and my overhead is rupees 25 per unit as per the computation in the earlier slide, and the subtotal is rupees 2236, which is 1843 machining cost, which includes of course manufacturing variable and manpower and tooling cost, machining cost, etc., and then marketing variable cost and overhead cost. So this works out to rupees 2236 per unit. We have to add to this vendor margin percentage to be negotiated, and similarly taxes on the machining to be negotiated. In fact, this is as per the statutory norm, so there is no negotiation, it is actual to be performed, to be confirmed. So the total cost of the machine item without the material cost works out to be rupees 2236 per unit plus percentage margin plus taxes for the our illustration. The important point is that the material cost, of course, will need to be added as per the cost estimate, as per the technology of the item to be machined, in case the material cost is in the scope of the vendor. Otherwise, normally industries, they also give their own casting or forging or bar stock to the vendor for machining, which can be steel or non-ferrous or any other material. Now, what are the pitfalls and negotiations for such kind of machining process with a win-win mindset? Uh, Here I've given 3 columns. One is the aspect, then pitfall, column number 2, and strategy. Now, first principle costing approach. Pitfall is the supplier treats machining cost as a black box, and strategy is ask for the breakup of the inputs, machine rate per hour, setup time, cycle time, tooling cost, etc., etc. Equipment cost, row number 2 is equipment cost, machine hour rate. So the vendor can always give a inflated hourly rate, So we have to just, negotiating team has to benchmark the machine specs, depreciation method and capacity utilization, etc. Cutting tool cost. The pitfall is spare charges, high tooling cost per part without any justification. So the negotiating must ask for the tool type, live data and tool change intervals. Likewise, I have given the various um, uh, pitfalls in each of the cost element, like manpower, manufacturing variable, vendor margin, taxes, etc., etc. So the strategies also have been stated here. Now, if you wish to learn more, please look at some of my vlogs which are based on the Udemy course. Now, this Udemy course was launched on 28 December 24, and as on status of enrollment as of 5/5/25 is that there are 5,307 enrollments with a star rating of 4.8 on a 5-point scale, and I've written 11 blocks out of this total course for the benefit of those who cannot buy this Udemy course. So there are 1,89,200 is the number of views or clicks by professionals, with 5217 as the watch hours. Let me clarify this. So this total 11 blocks, the recording time by me is 2 hours 23 minutes, and people who have viewed this, professional who have viewed this is 5217, 5217 hours is the watch hour time, which is more than 2000 times of the total time talked for recording, indicating that the professionals are really making use of this. Likewise, I have I have got 85 logs posted, which includes some 75 logs related to my books on business ethics, and the total number of views on my YouTube is 13 lakh plus. This is includes 11 blogs related to the course and 74 related to the business ethics. And my first book was ranked number 1 on the Amazon India. You can look at, I have given the references links for the Udemy course as also for the YouTube. And in any case, my website link is given below in this slide itself. Thank you very much and happy learning. Hope you enjoyed it. Please make use of the resource templates.